Hey everybody, in this video we're going to take a look at how we can find inverses of functions using various methods. Right? So as you can see here, we have one method is finding inverse by undoing. We have finding inverse by verifying these conditions. We also have finding inverse by swapping inputs and outputs, and also by graphing. Right? So one of the first things we want to do is essentially check to see if these two functions match. To do so, I'm going to find the inverse using by undoing of one of these equations here. So I'm going to do that for f of x, and I want to see if f inverse x will match this function g of x. Right? So let's go ahead and get started. So one of the first things we should do first is to figure out, okay, what's our order of operations when doing inverse by undoing, right? So when I plug in an x, you kind of have to think about what is the first operation that goes when inputting x, right? So the first thing we should do in this case is let's try multiplying by 3, right? Because there's a 3 up here. And now I'm going to divide by 5, and then I'm going to subtract by 15. Okay, and the concept of inverses essentially is the inputs, right? We have outputs here, and the outputs of the original function becomes inputs of the inverse. So in this case, we're actually going to go backwards now. So to undo this negative 15, we just change it to positive 15 because we're adding, which is undoing subtraction. We're going to multiply by 5, and then we're going to divide by 3 because those are the opposite operations. So in this case, our inverse can look like this: f inverse x, right? So we have our x, add 15 first. We're going to multiply by 5 and then divide by 3. Right? So add 15, multiply by 5, then divide by 3. Right? So the next step here is we need to try to see if we can simplify this equation so that it looks something like this guy over here, g of x. So that's what I'm going to do. So I'm going to multiply 5 to everything. I get 5x plus 15 times 5, that is 75. Quick maths right there. Divided by 3. Okay, so we're so close. We just got to do one more step. 5/3, that's just going to be 5 over 3x. 75 divided by 3, guess what? That's going to be 25. Right? So this is the inverse of f. Right? And lo and behold, if you look back up here, doesn't that look just like g of x? That's crazy, right? So this is going to be g of x as well. So we can say that these are inverses. It's very nice, right? So let's go ahead and move on to the next one. So the next one here is finding the inverse by verifying these conditions here. Right? So one thing I'm going to do is I'm just going to do this one here for the sake of this video, right? So what I'm going to do is, as you can see, I have j of x and I have k of x, right? So one thing I need to do, I'm going to figure out, let's just denote this as f of x just for this sake of this example here. And this is going to be f inverse x. So I want to see if these two are inverses of each other. So what I'm going to do is I'm going to plug this guy, because this is f inverse x, into this x right here. Okay, so how that's going to look is like this: f of inverse f of x. Okay, and yeah, let's plug it in. So I get 2 divided by f inverse x. Right, so we got let me see, 2 over x minus 10 there you go, plus 10. Right, looks kind of funky, but that's okay. So then yeah, let's go and figure this out. So because I'm dividing by a fraction, there's a few things we can do here. So one thing I could do is change it into multiplication, right? So I can change this to x minus 10 over 2 plus 10, right? So now, as you can see, we have this giant 1 over here. So this can become x minus 10 plus 10. And lo and behold, look at that, we got another giant 0 right there, right? We got x. So as you can see, I proved that f of f inverse x is equal to x. And that satisfies our original condition right here. So therefore, these two here, j of x and k of x, are inverses of each other. Right? Very nice. Right? So we got a few more steps here. So one thing I'm going to do is find inverse by swapping inputs and outputs. Right? So essentially, when doing that, I would recommend changing this into y. So in this case, I have y is equal to x minus 10 squared over 4, right? And the other one is going to be, this one right here is going to be y is equal to 4 square root of x plus 10. Very nice. So I'm just going to swap one of these functions. So let's try it with this one here, right? So what I mean by swapping inputs and outputs, this is the output, this is the input. I'm just going to swap them. So I get x is equal to y minus 10 squared over 4. So the main goal here is to try and see if I were to solve for y, will it match this equation here? I don't know. You just got to find out. So let's try it. We got to solve for y. So one of the first things I should do is multiply by 4 to both sides, so I can get rid of this denominator. So I get 4x is equal to y minus 10 squared. Right? You can see that? Nice. So now what I have to do here is to get rid of this square, I just need to square root both sides. So this is going to give me the square root of 4x is equal to y minus 10. Okay, see, the square root's all gone now. So now the very last step, actually not the very last step, somewhat, is we got to add 10 to both sides. So in this case we get 4 square root of 4x is equal, plus 10 is equal to y. Right? So the very last step technically is you can take the square root of this 4. So I can say that y is equal to 2 square root of x plus 10. So now this is what I get. Does this match the other equation? So unfortunately, if I were to move this back over here, right, we get 2 square root x plus 10 equals y. And unfortunately, they do not match, right? So what does that say? That just tells me that these guys are not inverses. So I can say e of x and d of x are not inverses of each. Right. So that's cool. That's cool. Now we're almost done here. Right. The very last thing we do is finding inverse of graphing. So it's very similar to essentially the last video, right? So let me get some patty paper here. Give me a moment. Woohoo! There you go. We got patty paper. So essentially, these are two graphs, right? So this m of x, this is actually this equation, this line right here. M of x is this line. And then P of X, that's going to be this line over here. Just like that. So now I want to see if they're actually inverses of each other. So right off the bat, I don't think they are, but we'll see. Because the fact of the matter is, when taking the inverses of graphs, we're always reflecting over y equals x. So this line here is y equals x, right? Just like last video, like I said, we're reflecting our equation over this line. So just like what we talked about, I'm going to trace m of x, and we're going to see what the actual inverse is. Okay, so I have my equation, I have my line of symmetry. I'm also going to do this little plus right here. Okay, so now remember, math magic's time. We're going to reflect over this y equals x. So I'm going to flip this over and take a look. So now I have my plus aligned to the origin, and now this is going to be my inverse. Would you look at that? So then now let's compare it. Unfortunately, this line here does not match P of x, right? So the obvious means that these two, m of x and P of x, are not inverses of each other. Nice, right? So if P of x was this line right here, hot dog, that would have been the inverse, but unfortunately it's not. So hopefully you guys were able to understand that there are 4 ways that we can actually do or find inverses of functions. So we have graphing, we have swapping inputs and outputs, we have undoing, and we also have this condition where I plug in the inverse of my function into the original function to see if it equals x. Okay, so half of these are inverses, half of them are not. So please be careful when doing these. And yeah, that's about it for this examples, or for these examples. So hopefully you enjoyed. I'll look forward to more tutorial videos just like this. All right, see you guys later. Like and subscribe.